Collective is a group of like-minded people from all around the world at different stages of their guitar building journey. You can join us over on our forum to seek advice or share tips on guitar building processes, materials and tools, or just to share your builds. On YouTube, we have a regular podcast of guitar building chat where you can join the live stream or watch back on past episodes. Our Instagram page shares posts of members' builds and links you direct to their accounts. And for those of you on Facebook, we've got a private group that you can join, share and chat along with. The Guitar Builders Collective is a welcome and open space for all, so do pop by and say hi. Great. Hello, people. Welcome to the Guitar Builders Collective chat. This week with a guest who's not a guitar builder. Over here, it's Ben. So just quickly before we introduce everyone, if you haven't seen us before, we're a weekly live stream. We talk about things that are often guitar building connected, but we've got Ben in today because of the processes he uses, and we can talk about how that maybe transfers across to guitars. And we also have a Facebook page, an Instagram page, a website with a forum where basically it's all set up for guitar builders to join and support each other, to give advice, to give a bit of encouragement and inspiration and answer any questions you've got. I'm sure we'll talk a bit more about that later on. We've also got a live chat for anyone that's watching along live. So if you've got questions, drop them in there and I'll share them with Ben and everyone else. But if you're watching in the future, put your comments in the comment section because we do check them and like to respond to people. Great. So we've got Mark here who's been with us for a couple of months now, at least, I think. And hopefully going forward, we're about to go through time zone changes. So it muddles up who can be here at different times. Just asking Mark off camera. Mark, we know from previous episodes, does a lot of CNCing and laser work, but you were saying you haven't really used 3D printing before, which is the topic for today.
No, which is a fantastic topic then, because we're all going to learn a lot.
Yeah. And then Scott down here, Bonehead Guitars. I can't point. There we go. I know, Scott, I've seen you use your 3D printer for some of your inlays. Is that right?
Yeah, that's about the only actual productive use of. I've printed a whole lot of stupid stuff, but yeah, I was just printing the outline of my inlay. I'd fill it with resin.
And Ben here.
Hi.
As you can see in the background, you've got a couple of your printers actually on the go, I think you said.
Yeah, so these are the two printers I have in my home office here in Brighton in the UK, and I do everything on these, and they're running pretty much 8 hours a day, every day.
Great. So we'll get into what you do with them in a moment, but just to say, I met Ben at a guitar show in Brighton, so local guitar show, last year. Ben was helping out because the guitarist in the band Ben plays with was running the show. And we started talking because I had, as well as my guitars, I had a microphone stand that I'd handmade, and it was quite a long process to make something that looked quite simple in the end. And I was sort of struggling with how you can justify selling something that takes so long to make, but doesn't really look like a massive thing because it was a one-off. And then discovered that Ben mass produces things that you make yourself.
Mm-hmm.
And harmonica and mic stand related.
Yeah, mostly. So I introduce myself. I'm not a guitar player or builder. I sing. I front a rock covers band, and I play the harmonica in that band. So for me, what I do is it was all about creating the things I needed for my own performance on stage that I couldn't find anywhere else. So if let's grab this guy here. So this is where it all started really. So this is a Shure Green Bullet microphone. So this is the world's best-selling harmonica microphone, and it's shaped so you hold it in your hand and you grip the harmonica like this, and you play this. But they don't have any way. Where have we gone? So the old ones used to have a sort of a screw thread on the bottom where they now put the volume control that used to be able to screw onto a microphone stand. But when I'm playing the harmonica on a few songs, like 5 or 6 songs in the set. The rest of the time I'm running around and I don't want to be burdened with this. So I was looking for a way to put this on a microphone stand, and there's nothing. Nobody makes anything that goes on to put a harmonica microphone on a microphone stand. So, as it happened, my son was about 13 years old at the time, and he'd been doing a sort of after-school engineering club, and he'd really been enjoying doing some 3D printing as part of that. So we bought him a 3D printer. So if you look at this red one back there, so that's a Flashforge Finder. So we bought him a 3D printer to play with for his birthday. So we had this thing, and I thought, well, okay, I'll make a clip for it. So some free online CAD software called TippyCAD, and I made a thing that looks like this, which is sort of just a little more than a plastic shaped cup, and that put that on a microphone stand, and it was great. And I was surprised to find that some people on eBay were prepared to pay money for that same solution. So it all started there, really. And actually, those harmonica mic holders, they are popular enough that I was able to invest in some proper injection molding. So for these, I couldn't keep up with the demand for these anymore on the 3D printer. So I actually have these now, sort of a high quality injection mold, and I'd sell about 1,500 of those a year at the moment, so that's pretty good. But I also make all sort of other things. So over here on this shelf, we've got the different. There's various different designs of these bullet mics. So I've got different clips that fit all of these ones. And some of them I'm having molded, and some of them that don't sell in such large quantities, I'm still making on 3D printer.
So just to step back a moment, what confuses me is that the mic that you said no longer has a clip on it, or a screw thread on it. Presumably the way it works with that volume underneath, that is really practical for someone playing a harmonica.
Yes, it is.
So it seems so bizarre not to have a way of attaching to a mic.
Yeah, Daniel, I was going to say the same thing. Like historically, since they put that volume on the bottom, what do harmonica players do with the mic when they're not playing? Do they just like put it in their pocket?
They'll do one of two things. Either they'll balance it on their amplifier. They'll just put it down on top of the amplifier, and they're round, and they're sort of egg-shaped. They could roll off. Or what you see people do very often is this. They'll just tuck it into their shirt when they're not using it. Or I mean, you can get sort of little neoprene pouches that will fit on your belt and things. But yeah, so I have it nicely on the microphone stand. And actually, if you look at this right here, so this is my stand I use at gigs. Down a little bit so you can see. Get everything in the camera. Oh, where are we? So there. So I've got these harmonica boxes. Put my harmonicas in like that, and I've got this clip here. So I make the clip, and I also make this little part here that attaches to the side. So I call this a side arm, and I've got my ammo clips. It's all a military theme. I love a good pun. So these are bullet mics, and there's a mic clip, so there's an ammo clip. And these heart boxes and things. So all those things that I needed for myself that I couldn't find anybody else making, I made them all on my 3D printer instead. So
I just find it so crazy that you were the first to do that, considering there's clearly such a demand because there's so many harmonica players.
Yeah, so it's not quite the first. There was a guy in Poland, I think, who was making things out of resin. So he had a resin mold, but it's easier, quicker, and cheaper to do it on a 3D printer. I mean, that's the take-home message really for it. It's easier, quicker, and cheaper than doing anything else. There's very little barrier to entry.
Hey Ben, can you talk a little bit about like the design process, specifically like you have the dimensions of the bullet mic, and then how you use those dimensions to kind of design your clips around it?
Yeah, so it's an iterative process really. I mean, the first thing you need is an idea. all these things would start with an idea or a need for something, and then a little bit of imagination in how to turn that into reality. And I say 3D printing is good for that because you can do your prototyping and you can get it wrong and you can adjust it and you can do it again. You haven't got to fork out thousands and thousands of pounds or dollars or whatever for making molds. So this is my most useful tool. This is just a pair of calipers. That's what you need. So my design process, if I take this guy, really is very simple. I'll just take my thing and I'll measure whatever it is I need to measure, and I'll draw it in my CAD program, and I'll print it out and see if it fits. And if it doesn't fit, I'll adjust it and do it again.
And so is there like a discrepancy between your measurement in reality and then what you do in CAD and then what the printer prints out?
So it's pretty accurate. I mean, there's about a 10 to 20th of a millimeter tolerance on that, and it can change. So if you're using a different material, you can have something that fits really snugly on one day, and just the temperature of the air or something inside the printer might make it just like that 20 microns a bit bigger, and it no longer fits or doesn't come in and out smoothly. But for the most part, they're quite flexible. So it's usually fine. And I have some online CAD software. There are lots of them about. Some of them are free, some of them are paid. There's just a web browser based program called Tinkercad, which is by Autodesk, and it's completely free. If you've never done any kind of CAD before, I could recommend it. It starts with some primitive shapes, and you can add them together, and you can use them to subtract from one another. And it's how I made this first one. Was just with a shape, fairly simple shape I made in Tinkercad.
And as far as like the rapid, sorry, Daniel, as far as like the rapid prototyping, like let's say your tolerances are a little bit off and it doesn't quite fit, you have to do it again. How long does one take to build on a 3D printer? Like how long does it take?
Yeah, so something like this, if you're printing it to sort of a low resolution, it'll print in about half an hour. When you get to but you don't need to print the whole thing either. You could just print you can cut it down into a slither that fits the profile and measure that. So, I mean, you can start in 10 minutes with your first try to see if it's done. Once they're finished, something about that size takes between 2.5 hours to print, depending on what resolution you want. But I have some other things. These half boxes, they're about 6 hours a piece to print. But this machine can print 2 at a time.
Is it 6 hours? Because I've seen those. Is it 6 hours a piece because they're in parts? So you're printing the 2 separate parts? Because they have an inner liner, don't they?
It takes 6 hours because there are about 800 layers, and each layer. So let me talk about the process of how a 3D printer works, because that's quite interesting. So you have your model. Let me show my screen. I'll just flip over to my.
What's your slicer of choice?
Yeah. So let me just share my screen if I can figure out how to do it.
I can see your red printer in the background, the filament moving backwards and forwards.
Yeah.
So obviously, it'd be great to see how the software using how the machine works.
Yeah.
I also want to get into the range of materials, because obviously you've just mentioned later on.
Have some time for that. So this guy here. So I've got in my CAD program here. Can we see that? Is that sharing?
Why is that? Sorry, technical things. I can't work out why it's not sharing. Oh, there it is. I've got to click that. There we go.
Yep. Okay, so this is one of my little side arms. This is the model for that in the CAD. So what it starts with, these different programs, they work a bit differently. So this is based on 2D drawings, this CAD. So it'll take a 2D drawing and then it'll extrude it or revolve it around various different axes. It's quite easy to get started. You've got sort of adjust your way of thinking a little bit, but I didn't find it too difficult to understand. So if it starts, so the process here just starts with this shape, if you like. So this is the profile of half of the middle thing, and then we'll revolve that here. So that becomes that. Then we do some other things. And again, cut a bit out of there. And then we cut a bit out of there, etc., etc. So that sort of builds up step by step, one step at a time. The really good thing about this is because it's procedural, if you like. So each of these steps on the left hand side is a procedure. So you can build up and refine and cut bits out and add bits on. And if at any time you want to go back in the process and adjust something, anything that happens up here affects the way everything gets rendered down into the next steps. Whereas if you're using a more of a modeling tool like Blender or something, you're manipulating those vertices directly. So if you want to change something, it gets much more difficult to go back to earlier steps. I have been trying to learn Blender. I find it really, really hard as a 3D modeling tool rather than a CAD tool. So the CAD tools lend themselves much better to this. Okay, so let's skip ahead a little bit. But once we've got that.
Yeah, I've seen Blender used by artists making more sculptural things as opposed to things that have a perfect tolerance, maybe.
Yeah,
so that's just a limited thing I've seen.
Yeah, so if we'll talk later about the skulls that we were doing, Daniel. That's more like what Blender is good for, making those models. Let's have a look at. So if we look at, do I need to change my screen that I'm sharing? Sorry, I've not used this before.
Don't worry, we always have technical things. It's interesting, isn't it? Because we've talked about CAD before for CNC. So it does feel like for people that are interested in all of those things, the CNC and the laser printing, there's a shared skill that you can have for all of them once you've learned. And everyone that was come on, like you, Ben, has said it's actually not hard to get into the CNC and the CAD initially.
Yeah, and one of these models that's produced by the CAD. I mean, a CNC machine will take that same object model as well as your slicer. So here I've got the slicer software. So this is FlashForge Slicer. It's the software that comes with the printer, and I've never had a cause to need to use anything else. It's really good. So once we've got that.
Hey Ben, can you take a moment and just define what a slicer is?
Well, yeah. So a slicer will take your 3D model and it will literally slice it into layers. Because the FDM or fused deposition modeling machine needs to work with individual layers. So a slicer is software that will take a 3D model, cut it into layers. It's a bit more complicated than that because there's all sorts of path material and it can do supports and everything. Yeah. Essentially, it's chopping it up into chunks that the printer can understand how to print one layer at a time, move up, print another layer.
Making a tool path.
Yeah, exactly.
However, it's got information in there for temperature and speed and all kinds of crazy stuff.
Exactly. So if I look at, see if I can find. Yeah, so this is the model in my slicer that we just had in the CAD program. I'm just going to very quickly slice that on the default settings. See, and then we can see what the machine is going to do from the bottom. So there's a bit of what's called a raft on the bottom, just to help everything be completely flat and smooth. And then each of these layers, and you can see here where the nozzle, where the print head is going to start on each layer as that works up layer by layer. That's what the printer is going to do, and that creates a file called a GX file, which is essentially just a set of vector coordinates like you say, Scott, with some temperature and speed information embedded in there. So that goes to the printer, and the printer does its thing.
I can see on the side there, where it says structure, there's a key for infill, solid fill, bridge. Are those elements quite important? Does that affect the way it prints?
They can be. So this particular one I've got no infill on this model at all, or this slicer, because what I'm looking for is strength, not lightness. This has got to clamp onto a microphone stand, and I don't want it to break. But if we just change some of those.
Hey Ben, real quick question on strength. Like if you were trying to print for strength, are you looking at the amount of layers, the material, or the orientation of the print? Like what are we talking about in terms of strengthening the piece?
Yeah, well, first of all, not all materials are the same. So some materials are bond together stronger than each other. So the way you're doing it with this kind of 3D printer is you're basically getting one layer of plastic to melt into and stick to the layer beneath it. The precise temperature at which you print can affect that. If you print too cold, things are not going to stick together. If you print too hot, you're going to get a lot of oozing and stringing, and you also might get dragging where instead of the layers going down, melting into the bottom layer, that layer below it actually starts to melt as well, and then that can lead to bad surface finish or weakness. So it's a trial and error. You've got to experiment and find out exactly what's going to work best for your printer with your material that you're printing for your model. But then once you found that, you should be good to go, and you can keep them going. But this one I changed the infill here to 50%, so you can see now in there you've got this sort of hexagonal internal structure, and that will save a lot of material. But it might make your part lighter, but and a lot of time as well. Yeah.
Well, I was looking at the estimated print time. How accurate is that?
It's pretty good. Yeah, it's pretty good. Yeah, within a few minutes. Yeah, and it'll calculate the how much material and stuff you need as well.
So you're mentioning about like melting one layer into the other layer. So in terms of like material and like toxicity, like how are these materials safe? Is there any hazard to this?
Yes and no. What I mainly use is a material called PLA. So that is a plant-based polymer. It's polylactic acid. So PLA, and that's very safe. That there's no toxicity. It doesn't smell. Very easy to print with, and it's the most popular 3D printing material there is. It's very cheap. You can get, but it doesn't. So there are always advantages and there are disadvantages. It's not very thermally stable. So if it gets hot, it will melt. I've had some of my products melt, or not melt, but start to deform and warp when they've been left in trunk of people's cars in California over the summer, just because it will start to deform at about 60 degrees C. Don't know what that is in Fahrenheit, sorry. But yeah, so there are other materials like ABS is very popular, but that is much harder to work with, but it's stronger, it's less brittle. So PLA bonds quite well between the layers, but it is quite brittle. It can, especially if you've got a thin model, it can shatter if you drop it or hit it. But if you've got other materials, so PTEG or ABS, they can be stronger, they're more thermally stable, they're less brittle, but they're a bit more toxic and they're a bit harder to get to print. So you've got to experiment. You've got to find out what works for you. I make some of the things I make. So some of these little gaskets and sleeves, I make the things, and they're and these devices as well, which I might talk about or not, that help you put your harmonica in a neck rack with a microphone attached to it. They're made of a material called TPU, tetrapolyurethane, and that also is very safe to print with. It doesn't smell. But
So the PLA, you said it was a plant-based.
yeah, it's made from corn.
Does that mean it's so you're doing your iterations and experiments? Is that just waste material afterwards, or can the PLA somehow be recycled? Because obviously plastic.
Everything can be recycled. It's just a question of whether it's worth doing or not. You can recycle your own filament if you're set up for it. You can basically crush it up again and melt it back into a filament that you can use again. You obviously lose some quality, and there are companies that do recycle. So I have a TerraCycle recycling box here, and they'll take, but they only want the ABS, which the spools are made of ABS. So I recycle my spools. And my molded clips as well, they're also made of ABS. So if I have waste of these, I put them in the recycling box. But the actual PLA itself is, whilst technically it's recyclable, it's not really economically viable to do it. It just goes in the bin, unfortunately. Now it is biodegradable. Or it's sold as being biodegradable, but it's degradable over decades rather than months. But not centuries. It will break down in the soil, and you can, in theory, crush it up and put it in your domestic compost collection. Because obviously they do it at a higher temperature, so it will degrade more quickly. But my particular local authority doesn't like it if you do that. Although it will work, they don't like it. So. But then, to be honest, the amount of waste that's generated is minimal, because it's an additive process rather than a subtractive one like a CNC machine. If you're doing CNC, then you're wasting 80% of your material.
Yeah,
in some cases.
True. Hey, sorry to jump in, Daniel. I know you had a question, but Ben, can you talk a bit about surface finish?
Yep. Again, so if you experiment, so yeah, if you click on that one, that one's got a pretty poor surface finish, and the reason is, in order to do the two colors there, I had to manually change the filament because they already have one head on the printer. But with the 3D printing, you will get layer lines. How prominent those layer lines are, again, are all a part of the black art of experimenting and refining settings. If you have more layers, obviously the distance between the layers is smaller, so the layer lines will be less obvious. So you can see this was quite a quick print, and the way I was doing it was just as an experiment, really. So I wasn't concentrating. It's quite a low resolution, and because I'm manually pushing the filament in each time, there's some extra layers. But if you look at if I can, you look at this one, if I can get that close up to my camera, that one there's a 3D print as well, and the finish on that one is about as good as you can get. I don't know if you can see the difference.
Just quickly connected to that, then your printer that you said can print two at a time.
Yes.
Does that allow you to print two colours on one thing?
Yes, it does. I'm glad you asked me about that, Daniel. So this machine here, the reason I got this, well, two reasons. It prints the TPU better than the other one because it's got a not quite sealed, but it's got an enclosed environment, so it controls its internal temperature and a heated bed. But it has two print heads, which allows me to save time by printing either the same model on each head at the same time. So rather than 6 hours to print a harp launcher, I can get 2 out in 6 hours. Or, like we have here, I can print the two colors.
I know Bamboo makes a 4-color printer.
Yeah. So you can get ones with multiple heads, and there are also devices that will they'll attach to your printer, and they've got a splicer inside, so you can feed multiple different colors of filament, and it will merge and splice them so that the single print head starts getting a different filament at each different part of the print. I have no idea how well they work. I don't have them, but I've seen that they exist. They look very clever.
Someday I want one. I really want to get a resin printer. I just have no real good reason for it.
Yeah. So I was going to talk about the different types of printing as well, because if you so my printers are FDM printers. They melt layers of plastic into each other. The other most popular type of home printer is a resin printer, and they'll just start with a pool of liquid resin, and then it basically shines an ultraviolet light into the layer, and that ultraviolet light makes the resin harden, and it lifts up magically your print out of this vat of molten resin. But I wouldn't recommend one of those if you've just got a home office that you're printing in. If you've got a workshop that's ventilated, then that's fine, because the resin stinks and will create a mess if you spill it.
And you got to be somewhere where there's no sunlight.
Yeah. But they have their advantage. If you want to print wargaming miniatures or something, and you're looking for a very high resolution, then an FDM printer is not really going to do that very well for you. I had a go. I got this little Goth Rocker here from Games Workshop. So he's the original model. So I took a 3D scan of him and tried to print him on my printer, and he's done okay. I don't know if you can really see, but it did lose quite a lot of detail. But yeah, but if you've got well, I think that's partly to do with the taking the scan as well as the print.
So is there a difference in the quality the FDM can print if you've got different machines, or are they all basically the same sort of quality?
No, so not all printers are the same. So it depends on how close you can get those layers and how small you can get those layers. So my printers print with a 0.4 millimeter nozzle, but you can go smaller. So if you really want that high resolution, you can go all the way down to 0.1 millimeter nozzle and a very low layer height. But your prints will be taking a long time to print.
Mm-hmm.
But generally speaking, if you need that resolution, you don't want to see any layer lines, you want that high quality, then you'd be better off going for a resin printer.
And is that printed using the same files? So you can use your same
CAD? The same thing. The same slicer software will do it. It's just a question of well, I don't know if the file will be different. The file you give to a 3D printer, an FDM printer, will be different to the file you give to a resin printer, because obviously it needs different information. But most of the slicers, I think, if you've got Pura Slicer, or there are plenty of other free slicers you can download. They will do. I'm sure they will do things for resin printers. And you'll usually find, if you bought a printer, it will come with some sort of slicer download link. So you'll always be able to have the right software. Software is just not a problem. Not a problem.
Just as he's here in the chat, we've got Ray in the chat from Custom Unlimited
Hi, Ray.
Designs, who is going to come on at the end of April to show us some of the work he's been doing with 3D printing and guitars. Mm-hmm. But we thought this was a good way also to get us into understanding printers with you. And he had a question. I know you said you use mainly the PLA.
Mm-hmm.
He said, have you used acetone with the ABS to get a smoother finish?
I haven't. No, I haven't.
But you definitely showed me something that you'd done one of your finishes too, to change.
Yeah, so I've tried. So PLA, you can sand PLA. You can sand it down and get rid of the layer lines, and then you can varnish it, and that works. I've seen some YouTube videos where people have got very, very good smooth finishes with PLA. It's not something I do just because it's not necessary.
It doesn't sand very nice. You can sand it, but it's not fun.
Yeah. It's not something I'm really concerned with. I did experiment in the early days, but I decided it wasn't worth it.
Yeah, I guess for your products, it's not essential.
No.
We'll talk a little bit later about what we've been experimenting with together. But yeah, we've been trying painting them as well, and it's some interesting results with that. So just back to the PLA though.
Yes.
Is it just available in a massive range of colours, or is it quite limited?
Yeah, if you go on Amazon and you search for PLA, you'll find hundreds. So they come in all sorts of different colours and finishes. So you can get the
Scott showing off his little collection there. Oh, how do I share Scott? There we go.
Yeah, you get some multicolored craziness.
Oh, so that's one reel with multicolour that changes.
Yeah, so I got some of those. So I've got this one here that has it's a very sort of matte finish. It's got a rough surface. It's quite nice, but it's not very strong. So I really like these. These print really well. If you're looking for something that doesn't need strength, but you want it to look really nice, they've got a really good finish, but it's not very strong. And then I've got some of these ones. This one's quite nice. And this is I don't know if you can really see it on the camera. It's the floppy octopus. Yeah. This one's got a. Oh, and actually, I think that the ones I printed in this were on the picture for the stream, promo picture.
Oh yes.
Yeah.
Annoyingly, I haven't got. Oh, there it is. Hold on.
Oh, and there's a blue one. But I was going to show actually also. Where is it?
This is Ben's setup for when he gigs.
So you had that one that changes colour, and I've got this one similarly that's got two colours. And this is quite clever actually, because if you look at the filament, it's green on one side and it's actually blue on the other side. I don't know if yours was the same as that, Scott, or
I've got a couple like that. I've had trouble with them feeding. They
right, okay.
And I'm not sure what the problem is. It could just be a temperature thing, or I haven't figured out what the deal is.
These give this really nice finish, so it's it's different color on one side than it is on the other, depending on how the filament's been. So that's a really nice sort of metallic finish. But actually, I found that these as well, the strength wasn't so great on that. But it depends on the filament. I find the silk filaments particularly are not as strong. My favourite one, the thing that gives me the best balance between strength and ease of printing, is called PLA Plus, which is a regular PLA. I can't say it, PLA, but it's got a few extra additives, just to make it make the layers adhere a little bit better. But I've tried with carbon fiber filaments and everything as well. They come out. The carbon fiber filaments come out really, really nice, but you need to get a steel hardened nozzle instead of your normal brass nozzles. They're quite abrasive. But they don't deform, so they won't warp while you're printing the carbon fiber model. So if you're looking for absolute precision in your design with repeatable results, the carbon fiber is quite good. But the carbon fiber is brittle. It's stronger in certain planes, depends where your layers are, but it's stronger across the layers, but it's brittle between the layers. So
on that note, I remember when I saw the harmonica holders, your ammo clips. Is that what you called them?
Well, so the microphone clips are called ammo clips. The harp holders I have are attached to my standard called V2 harp launchers. They're in a V and they hold two harps. Yeah.
They had They had two materials you used.
Yes. So the inside. So they have got a. It's basically just an ABS a TPU. So the soft rubbery insert into the hard plastic, because as you put harmonicas in there, they rattle. So it's just got a soft insert. But I print those as well. That'll come out.
Awesome.
And I know something that Mark might like is you also showed me that for certain parts, like the threaded inserts that you use,
yep,
you just buy them en masse. marks it.
I do, yeah. So I
using things you can get off the shelf.
Yeah, the little brass inserts that go. Well, actually, this whole bit, I buy these in from China. Yeah. I only make things you can't buy.
So, one thing that I'm interested in, if we step back a bit, is the actual machine itself.
Yep.
So, for someone looking to experiment with this, what should we be looking for? And anyone, obviously, if you're in the chat and you've got experience, drop it in as well. What you think? Yep. What sort of thing is the best way to start off?
I think ease of use really is the best way. There are plenty of entry level printers out there. This one I've got the red one on the side here. This is called a Flash Forge Finder, and I could recommend that as an entry level machine. They're about $300, I think, and they're very easy to set up and get going. Yeah, but there are all sorts like anything. You can start with the easy ones, and when they don't do what you need to do, you can upgrade once you know a bit more. But you could say they start at a couple of $100, but you can go up to tens or hundreds of thousands of pounds for industrial scale ones. So anything between. But you'll find support if you go on Facebook. There are support groups for all the different printers, and everybody's always keen to tell you that you're printing too hot, or your bed's not level, or you need to change your knob because it's clogged.
But so I know you said you're printing 8 hours a day, basically. 5 days.
Pretty much. I wouldn't say they're going all day every day, but they're going most of the time, most days.
And I remember you saying that that red one, is that your fourth one of those? Or?
Yeah, that's the fourth one I had.
So obviously the fact that they burn out because you're using it so much, but you haven't upgraded to a more industrial one, implies that it does exactly what you need, really. Then. So
I had when my first one. So I had one to begin with. My first one burned out 3 days before I was going to a 3 days before I was going to a show, and I needed to print some stock. So I bought another one, and it turned up the next day, and because it was the same as the other machine, I just plugged it in and it just started printing again, without changing anything. I had 2 more since then, so I had 2 of these red ones going, but actually before the previous one burnt out, I upgraded to this other one, which was a bit more expensive, but can do more things. So the main differences between these two, they're both Flash Forge. So this is a Creator Pro 2, and this is a Finder, but this one has 2 heads, and it's got a heated bed and an enclosed print area. So that makes it much more versatile. It can print lots of different materials. On the Finder, you're pretty much limited to PLA. It doesn't print anything else very well. I have got the rubbery TPU things to print, but this other one is much better at it. So you can print nylon or ABS or PTEG, and the flexible filaments as well all work really well on that. It's also got finer stepper motors. I think this one has got 20 steps per millimeter, and this one's got 100 steps per millimeter.
There's a bit of chat in the live chat at the moment about bamboo.
Bamboo, I've heard of bamboo. I've seen some good things said about it online. Well, from content creators who may have been paid to promote it. I don't know, but I haven't used it myself. But it's a new brand. I think they've only been around for a year or so. But
I feel like with this idea of it being a new brand, it's becoming more ubiquitous that more and more people are getting these printers. So you can do so much with $300.
I would say, I'd go out on a limb and say that a 3D printer is an essential tool for every household. Really, I've done so much with these that just for domestic things. For example, we lost the plug to the kitchen sink. I printed a new plug.
Brilliant.
we had a cat basket, taking our cat to the vet, and one of the catches on the cat basket broke, and we couldn't close the door. So I mocked up a quick model in the CAD and printed a new catch. I print quite into Warhammer as well, so I print these Warhammer objective markers on there and stuff. So much you can do with a 3D printer, and you can make things that you can't buy. I mean, you couldn't buy a new catch for your cat basket. They don't sell them, but you can make it on a 3D printer, no problem.
We'll go back to printing at the moment, because here Ray's just mentioned about failed print rate has gone down to less than 1% because he's been using this better printer. That's what I was intrigued about, because when you see things printing, they often don't print like just as you expect, a flat thing. They're printed at angles and things like that.
Yes.
So can you explain a bit more about why that happens and how that works, and how you plan that?
It's about your design process and your you've got to design your product to be printed. So what FDM printers can't do specifically is print overhangs. You can't print in thin air. Each layer needs a layer beneath it to stick to. There are ways around it. There's what's called a bridging mode, where you can just stretch a piece of filament, will bridge a gap, and then print the next layer across that bridge, but it tends to sag and it's a bit untidy. Or you've got to put in supports, where you sort of removable supports. If we have a look at, let me load.
So when you say put in supports, is that something you have to do, or is that something the actual software does?
So the software, let me share my screen again, and I'll show you in this. Oh yeah.
It'll auto-generate. You can have a little bit of control, but
yeah. So if we do, there's not much on this one at least, but I've got this support generator here, so you can just put these supports in. So it will calculate where your overhangs are, so you can tell it again various settings about how much overhang you want it to put in supports, and it will do that. And then these things are printed at a much lower density than the rest of the model, so they'll just, well, the idea is they just snap off, but they can leave some scarring. For some of the time you want to design for printing rather than I've got that one on there as well. Let's just delete that one. So these ones, for these kind of clips, I build the supports into the design. So this one rotates that surface to the platform. There. Oh, what's happened to that? Oh yeah, that's right. Move center. That's right. So for this one, I build the supports into the design. So these thin pieces here are designed to just cut off very easily, and I print this at a 45-degree angle as well. Because if this is at a it will print at this angle with no internal supports. If we put that back edge on the build plate, we'll have a horrible. Let's just rotate that in this direction here a bit. Okay, so if you print it like that with this bit flat on the base, then you'd have some nasty overhang at the top here.
Yeah, right.
So you've got to figure out what is the best orientation for your model to print and design that in.
Is there a way to make something in two parts that then seals together? You can heat it together or something.
Yeah, you can do that. You've got to get the tolerance right, because you don't want them to be too loose. Or you might want to glue them in. But there are lots of techniques for. We don't get too much into the weeds here, but there's some advanced modeling and 3D printing techniques where you can make crush structures. So if you've got two parts, you've got something with a peg, for example, that you want to fit into a slot, and you want it to be able to go in but never come out again, you can design some crush structures onto the inside or not onto the female part of that interface, and you can push a peg in, and those crush structures will collapse. But once they've collapsed, they'll hold that part absolutely rigidly, and it will never come out again.
Yeah, I've found super glue doesn't work very well with PLA.
I find super glue works really well with PLA.
Really? Because
Yeah.
every time I try it, it's like it refuses to dry when it's.
Okay.
I've had trouble with it.
Mileage will vary. Let's just say.
I guess, does it depend on the brand of glue or the brand of PLA?
No, I don't know.
Yeah.
Don't know. But I found super glue works really well.
Okay. Well, usually I'm trying to, small parts, something breaks, I'm trying to stick them back together, and it's just nightmarish. It's like it refuses to dry when it's on PLA. It's weird.
Okay.
Maybe it just doesn't like me.
Maybe. What do I use? I use this.
I wondered if there was something that was better suited for that type of stuff.
Well, actually, I would have thought it was all the same, because whatever brand of super glue you're buying is still just cyanoacrylate, isn't it? So
yeah.
Ray's suggesting using a solvent adhesive.
Solvent adhesives don't work on PLA because the PLA is very chemically resistant.
Yeah.
That sort of comes back to the smoothing argument. If you're printing ABS, you can smooth with acetone, and in that case, probably a solvent-based adhesive might work well. But just about the only thing that will melt PLA is called tetrafluorohydrazine or something, and it's viciously toxic and nasty. Don't recommend it.
Oh, Ray's saying that you should definitely try weld on 16 because it actually
weld on 16. Okay.
I know that there are different types of weld on because or that sort of solvent adhesive, because I've seen Adam Savage talk about it with all his different prop building, how he's got a range of different solvents that he uses for his different plastics.
Yeah.
So Ray saying was quite surprised that it worked, but it's always good to have a little tip from someone else like that. What I'm intrigued about the printer, or what I like about the PLA, is that it's not toxic, etc. But is it quite a noisy machine? Does it give off lots of heat? What's it actually like having it around you?
It's fine. I mean, I say these two machines when they're going are quite noisy in the background. But it depends what they're doing. Actually, this one is noisier than the other one. I don't really know why. It just is. But I live with it. I mean, I do my work. My day job that I do in here, and these printers are going in the background, and I go on meetings and people don't notice them, and I just tune them out.
It would be great if anyone's watching to maybe comment in the comment thread or in the chat about how you would use this for guitar building, because like when Ray comes on in a few weeks, he's going to show how he builds whole guitars out of it, but obviously there's a limited size to how big you can print. But what I've noticed is that there's so many more jigs and tools, etc., being built by guitar builders or people that want to help guitar builders that are all 3D printed and then selling those.
Well, what I was going to say as well about getting started, it's very easy to get started. The barrier to entry for 3D printing is extremely low. The machines are cheap. Even if you don't want to design anything yourself, you can hop onto Thingiverse, and you'll find, well, if you want to print plant pots or pitch frames, or it's like peg winders for guitars and other hooks and other guitar accessories. You can find ready-made models on Thingiverse for those, and you can have a crack, and I say
Yeah, I've seen loads of
once you've started, once you've got a hammer, you'll find lots of nails to bang in with it.
Yeah. So here's the thing. That I've noticed is with 3D printing, go on Etsy, people are selling things they printed. Go on Thingiverse and you find the files for those things. So some people, if you've got the printer, you can print them at home. So presumably, if like I'm not sure I'm going to do this yet, but I'm beginning to find more files for guitar building jigs, like Owen's just mentioned, using it to make radiusing blocks. Then if you're going to start buying loads of them, then maybe buying the printer itself and just printing them is the more viable option there. But what I'm interested in is you as a business being able to sell your microphone clips. It's like so on a tangent, my brother sells beard oils and things, and it's a similar type of thing.
You can tell that you use those, Daniel.
Pardon?
You can tell you use those yourself.
I do use them, but I don't have a proper big beard to use it really. But so when I talk to him about how he sells his products, it's much more like I imagine you sell yours. And if we had Jack from JC Guitars a while ago, who makes lots of small products with offcuts of his guitars, it's a similar thing. But when you're selling a one-off guitar or something like that, it's totally different the way you advertise it. So I wondered if you don't mind talking a bit about how your business works and how you sell, because I know you sell in multiple countries as well.
I do. So I sell most of my most of my ammo clips for the Shure Green Bullet. I mostly sell those on Amazon and eBay. To be honest, so I've got a Wix website that I set up, but I don't. So the Wix website is a showcase really for my products. I don't tend to make many sales on the website. Some, but not a lot. So mostly it's either Amazon, particularly in America. Amazon in America love the 520 ammo clip. Or I advertise on Facebook as well. I don't tend to do paid ads on Facebook. I tried doing paid ads on Facebook. I didn't really find that they worked very well for me. Either I'm doing something wrong and not finding the target audience, or I am, or Facebook algorithms are not understanding what it is that I'm trying to sell.
So how are you advertising on Facebook if you're not doing the paid ads?
So I'm just part of the harmonica microphone and harmonica gear discussion groups on Facebook.
Right.
There's like all these things. It's a small community relatively, but globally is actually quite big because there are a lot of people in the world, and you've got to go where your market is. I think that's the message. I'm involved in some harmonica groups, so HUK, who are the sort of official, if you like, if there's an official thing, they're the official custodians of harmonica related things in the UK. And I'm involved with a harmonica festival that we run every year in Brighton. And I know some of the people. I haven't managed to get over to SPA in America yet. I'm hoping to do that. That's the society.
Hey Daniel, I gotta go.
Oh, all right. Take care,
guys.
That's the Society for the Preservation and Advancement of Harmonica in America. But I say, yeah, you got to go where your audience is. Sometimes it's tricky to do that, but Facebook is a great resource for me. These things sell themselves on Amazon.
And the way Amazon works, you send a bulk to their fulfillment center, and
yes, correct. So I send my clips in bulk to. I say in bulk, 100 at a time, to Amazon in America, and they last about a month or two. And I send a box about every 6 weeks or so, I suppose, to America. But I also have products in Amazon warehouses in Australia and in Canada, not in Europe. Because selling in Europe from England is harder than selling in America or Australia. It's bonkers, but let's not get into that. So that's it really. I don't say I sell a huge volume. I do what I do as a part-time hobby really. I mean, I've got a proper day job that keeps me busy during the day. So I do what I can do in my spare time. I put more time and effort than scale up, but at the moment it's what I do.
Ben, we're just slightly losing you there.
Oh, sorry.
Oh no, you're back. You're back. It's fine.
Maybe some bandwidth problems.
I forgot to check with you because obviously Mark had to leave at the end of the hour. Are you all right? We normally carry on a bit longer.
Yeah, it's fine. Yeah, I've got.
Cool. If you need to go, just tell us. I feel like you've covered so much that my brain needs to absorb it all to want to do it. I guess one of the other questions I've got is, if you are interested in like experimenting with the CAD programs, looking what's on Thingiverse, are there places you can just send your files to print and they send it back to you?
You can, yeah. You can buy on-demand print surfaces. They are not necessarily cheap. They're certainly not as cheap as doing it yourself. But if you just want to have a go, then there's trying to think of some names of people. Formulabs will do it, but I think it's just a Google service as like on print surfaces. Services, not surfaces. Services,
Yeah, I've never looked into it. I know there are some, but
But I mean, they're not cheap because they're running as a service business. So even for a small part, you might be looking at a couple of £100 for them just to print you a single part as a prototype. And to be honest, you might as well spend that money on a printer. Yeah.
I guess I was thinking towards, we had Ken from Tunguska Guitars on Kent, a few weeks ago, and he had they'd been laser cut, but he'd made some templates for what he was doing, and he'd drawn them all up in CAD and had them made. And they're things he's going to use over and over again. It just occurred to me that if there's something very specific you want, people are saying they use it for their templates, but you only needed a one-off. Was there a way to sort of do that? But I guess as well, it's going to be, if you do it as a one-off, you're going to start get addicted.
Yeah, well, I would say ask around. These things are out there. You'll find somebody with a 3D printer. If you ask around, you can get somebody to do you a favor for a one-off thing, I'm sure. The other thing I was going to say, as a really useful thing, I'm in contact with a guy in the Netherlands who makes microphones. He makes harmonica microphones. So what he uses his 3D printer for is for making molds for gaskets. So you were saying earlier about making jigs and things for guitars. So what was really good is, if you don't want your part to be 3D printed, you can 3D print a mold, and then you can use that mold for resin or silicon or whatever. They're really great for that. And you can do, and then it's worth spending whatever time you want making the inside of that, polishing the inside of that mold, so you get the finish you want on the final product.
I'm trying to think, is there something obvious we've missed about 3D printing as a way in? But it feels like we've covered everything that I can think of. I want to get into more in-depth things in a moment. So when I met Ben, I mentioned, I know what I wanted to ask you about: injection molding. You said that because some of yours, you have more of a demand for it, it's not worth doing it on your 3D printer. For those of us that don't, or people that don't know what injection molding is, can you say a bit about that?
Okay, so injection molding is a much more industrial process. It's a mass manufacturing process as well. So most plastic things you'll have in your house have been injection molded, or some variation of that. Your television remote control, the casing to your computer monitor, your milk bottles, or whatever, they're probably mostly injection molded. And that is, so you start with a steel mold, and there's a machine that will melt some plastic and fill that mold with plastic, and then let it cool and spit it out, and it can repeat that process quickly and reliably thousands of times. So where my clips take about 2.5 hours to make on the 3D printer, the injection molding factory can churn out 2,000 of them in an afternoon.
So for them to do that for you, they make, presumably they or you employ someone makes the mold for
Yes,
you, but
so
using the same files you've already got.
Yeah, so it's exactly the same file. So I sent my same CAD file that I used for my slicer. I sent that to the injection mold because they had their partners in China make the mold. They shipped it back, and they do the injection. But the difficult thing there is making the mold. That is many thousands of pounds worth of investment in making that mold. And if you get it wrong, you've got to do it again. So that's why your rapid prototyping on a 3D printer it's a game changer because it removes barrier to entry. I mean, I was talking to the manager of the factory I use, and he was telling me that somebody else had said to him, you know, are you worried about all these 3D printers like coming and stealing your business? He said no, because it's actually increased my business because it removes the barrier to entry for people like me. I can get a product to market and prove that there's a market for it, and then I can make the decision to make that investment. Whereas if I couldn't have done that, I wouldn't have been willing to take the risk. And you know, there are thousands like me. There's nothing special about me.
Yeah, no,
all you need is an idea and the will to put it into practice.
I guess it's unlikely any of us are going to want to set up a company that makes jigs and things, but like I said, there are a few companies that are doing that. And if they were popular enough, then I guess that mass production might be the next stage. I wonder if I would imagine the proportion of people in the world that are harmonica players and the proportion of the people in the world that build guitars is quite different. I imagine there's quite a lot of harmonica players.
Yeah. So there are. You're not comparing apples to oranges there. Well, no. Yeah. So there are a lot more guitar players than there are harmonica players. The guitar market is vast compared to the harmonica market. So there's going to be a lot more people making guitars and guitar parts and supporting that industry than there are people making harmonica parts and supporting that industry.
True. So I guess if we can make parts. I mean, I've been thinking for a while about how to make it. So it's something I'm kickstarting soon is a guitar that I'm making, but I've been thinking about how to kickstart or how to make just parts, like so customized pick guards and scratch plates and things. When I met you, that kind of handmade Skull guitar, which annoyingly I should have brought it in, Skull mic stand, I should have brought it in here, was something that I really enjoyed making, but I couldn't see a way to do it en masse because it was so costly. Well, so that's how we started talking.
Yeah, so that's where we started when we were at the guitar show. I saw your microphone stand. Oh, yeah, I like that. And then I saw the price ticket you had on it, and I didn't like it anymore. You correctly, say that, in order to make that, it took you a certain amount of time. In order to pay for your time, there's a price associated with that. So, I mean, things do take a long time to print on the printer sometimes, but it's machine time. It's not something you have to spend your time doing. Once you put the investment to get it going, it can just okay. So it takes 8 hours to print. Well, it'll be done whilst I work on my proper job.
Right.
So I could just quickly share. I've got a video here. Oh no, pressing all the wrong buttons.
I've probably actually got about 10 minutes left or so, if that's all right.
Okay, I won't bother talking about me then.
No, I didn't.
I will very quickly just share this then. So this is a couple of them. I've made a few now, and they were handmade skulls that I then or customized skulls that I made a silicon mold for, then poured the resin in. Each one had to be individually poured, then assembled, and it was like, I don't know how many hours of work it was, but it was quite a lot of hours to hand make them. But once I've got the molds, it was quicker to make more, so I can reduce the cost with each one I'm making. But I don't really enjoy using resin very much. I started using resin when I was at university 20 years ago, and I just feel like is so toxic. I'm not enjoying using it very much.
Yeah.
And there are different types that are less toxic, but they're not as good, really. So when you were talking about the process, it was of 3D printing, it was so much more interesting. So I was hoping you could quickly mention. I've made something for you, but can you mention how you're taking a 3D model into a?
Yeah. So this is you made this skull out of this clay. So it's been something I've been wanting to do for a while. Actually, is getting to sort of 3D scanning and printing. So again, I bought just this little handheld 3D scanner. It's an amazing device. Again, technology you can get these days is bonkers, but it shines a sort of a laser beam around and can measure the distance between all the different points. It'll take thousands of points. Don't have it set up, so I can't demonstrate it. But I did that, and this is the 3D print I made the other day of that skull. So they are.
So we were
lined up probably. They're essentially the same.
Yeah. So what we were talking about is that skull that I made is a quick experiment just to see how much detail transfers across in the scan and then the print.
Yeah.
And then we've talked about how you're going to use the software to incorporate the clips into it, so cutting away into the head, so you can swap in and out the clips.
I don't have it. I can't find it. But yeah, so I could take that model then and import that into my CAD software, and I can use the CAD software then to cut slices and things through that model and make a microphone clip and put a screw thread on the bottom. What I was surprised to find is that you can 3D print a screw thread, and it works pretty well.
Oh, that's really interesting. Yeah, because we were also talking about this idea that once you've got one model, you can enlarge it, shrink it for different purposes, and it just seems so versatile as a way of, unlike the one that I made, where I handmade one, then you cast it in silicon, but then I can't change that. I've got to remake it, remake a new mold, and it's all quite costly and time consuming. That's the techniques I learned when I was learning sculpture at university. And this is just a totally different way of being able to manipulate, have iterations. It's great.
Well, that's kind of why I was sort of wanted to take some time to learn Blender as well, which is a sort of 3D modeling tool rather than the CAD tool, because it can import this into Blender, and then we could sort of raise the eyebrows or flatten the nose or something. And
yeah,
but I'm not really understanding it at the moment. It's a much bigger learning curve.
I'm intrigued to have a go, but it's like there's so many things to do.
Yeah.
When I met you to collaborate with, it just felt like
it's going to be constrained at the time. You've got to pick your battles.
Yeah, exactly. And finding someone to collaborate with who's got those skills was brilliant. So
yeah, I mean that's the thing I could do rather than sort of trying to learn Blender myself. I could just hop onto Fiverr and find somebody. I'll send them the model. They can do whatever and send the finished model back. It's a perfectly great way to do things.
Scott, with your printer, I know you said you printed some outlines that you filled with resin for your inlays. Have you ever thought about using it for guitars in other ways?
Yeah, I don't know if I'm just not that inventive or what. I haven't thought of a lot of good ideas to incorporate it. But then also I have the one of the bottlenecks for me is I don't really know how to use CAD or anything to produce my own models, and I mean that would kind of be a prerequisite for most of my ideas, if I had ideas.
Well, hopefully in a few weeks' time, it's on the 25th, when we've got Ray. Where's the date? 25th of April, and he's showing us some of the things that he makes that will help us maybe think about ways of using 3D printing in the guitar itself, as opposed to just tools and things. Out of interest, and Ray's just asked, what model printer have you got, Scott?
Ender 3 S1. Reality.
Okay.
It sounds to me like the printers, the budget printers, are so much better maybe than the budget CNCs, which seem a bit more limited.
That's probably true. Yes, that's probably true.
Yeah.
Was that Creality printer, Scott? Was that something you had to put together yourself? I know some of them come as kits that you have to assemble.
I did have to assemble, but it was surprisingly simple. And see, I started from I knew nothing. It was almost an impulse buy on the level that I don't do because I knew nothing about it. So did a little bit of research, and it seemed like a good entry. So I've had fun with it. It was a good way to get into it and get used to some certain things and learn some of the ins and outs. I haven't really been able to fine tune it too much to get really, really nice, clean finish or anything. But like I said, I've had fun with it. I have noticed when there are problems, when something does kind of go off the rails, it can be pretty tricky to figure out exactly what the problem is and get it fixed.
It can be, and so sometimes with it, like with my red printer, after many hours of trying to diagnose the problem, you end up at the conclusion that the motherboard's burnt out, and that's the problem. And then, you're looking at the new machine, because whilst in theory you can change the motherboard, it's not. The motherboard is more expensive than the whole new machine.
Yeah.
And especially with my first machine as well, I stripped it for parts and I sold the parts for more money than it cost me to buy a new machine.
Oh, that's brilliant.
Well, I ran into one of the problems I ran into was the feed wheel. I haven't actually seen it. It got to where it had some problems feeding, and it's not easy to get in to actually see the damn thing, and I didn't bother, but I wound up getting a whole replacement for the whole assembly that the hot end is in.
It can be quite scary to have to strip down the hot end and disassemble it to clear a clog or something, but once you've done it a couple of times.
For some of it, I mean, for just getting to the hot end and clearing that type of thing. One of my early problems was not knowing that you needed to have it up to temperature when you actually tightened the hot end on, because I'd gotten a replacement that could handle a higher temperature, and it leaked.
I stripped the thread off my first hot end by trying to disassemble it while it was cold. Yeah, I made it.
Yeah, but I didn't know. It makes perfect sense. You want it up to temperature when you tighten it on, but I didn't know that. And it introduced a very slow leak that turned into a giant mess that you didn't know was happening until it was nightmare level. But that feed wheel, I just wound up getting a whole new assembly, and I think it cost me, close to $100. But so that's the thing I've run into. It seems like early computer people, were actually just building shit and putting things together, and it was a hobby on a level that was not accessible to most people. And it seems like this is kind of just barely off the ground from there. They've incorporated a lot of things in there that will help mitigate some issues, but still, when you run into actual problems,
It's true, but unlike those early computer days in the 1980s where you have to assemble your own Acorn computer from the box of chips, it's easy to find support online and on social media. Very easy.
That's one of the amazing things.
And these, I use these. I haven't changed these machines because I haven't needed to. They do everything I want, and they're very easy. They come ready assembled. All you've got to do is plug them in, take off the clips so they're holding them together. And this one I've had for 18 months or so. I've never done any maintenance on this machine apart from oiling the rails. I've never had a clog. I haven't changed the hot ends. This other one I tried to replace the nozzle and clean it after about every 1,000 hours of printing or so, which is not very often. But the other one I haven't touched. It's been very, very easy to use.
Yeah.
Amazing. So listen, I know you've got to go, Ben, in a minute. So thank you so much for being here. Anyone that's watching, I've left links in the video description to Ben, Instagram, etc. It'd be great to follow him on Instagram, at least. and hopefully at some point in the future you'll see some collaboration between the two of us there, which I'm looking forward to.
Please feel free to ping me. I'm happy to answer your questions, and even if maybe you need something printed, I can print you a one-off thing, or help you design something. I'll be happy to chat with you.
Well, that's cool. Thanks, Ben. And also for people watching, if you subscribe to the playlist that's also in the description, or just to me, you'll see the future episodes. So next week we've got Jesse from Jaybird Guitars coming on, partly talking about his guitars, but what I'm interested in is he used to work for Gibson. So talking a bit about when he was working for Gibson and what that was like. Then we've got Corey, of course, is coming on to talk a bit about him and his guitars, and he's very prolific in building guitars and quite experimental, I think, but also a bit about the Yergs Cup. So and Arran will be back with us next week, I believe, or the week after. We've got then Ray coming up at the end of next month to talk about his guitars that he's actually making. And what I find interesting about Ray's guitars is he's selling the files for his guitars. You can buy guitars from him, but you can also just buy the files to make them yourself, which is brilliant. I'm just laughing because we've got comments about my hair. Yeah. So I always used to dye my hair for years, 10 years or so. I had dyed hair, and then I haven't for a few years. And then my 7-year-old said to me the other day, "Can you dye your hair green again?" So they were away last weekend, the girls. So I did my hair, and she just didn't seem impressed at all. So wasted time, but there you go. I feel like my old self. All those years of putting on weight are in the past or forgotten about, and I've gone back to the past. Yeah. Cool. So thanks again, Ben, and thank you everyone that's in the chat.
Yeah,
great. All right. Take care, everyone.
All right. Bye.
Are you looking for an excuse to build a guitar? Or do you just want to be part of the community and see other people's builds? Why not take part in the Yergs Cup? It's a community build-along where anyone can take part by simply sharing your builds either as photos or videos on social media and using the hashtag Yergs Cup. You can engage in conversations in the comments section and get feedback from others. The build-along is named after Jürgen Zoller of Zoller Guitars, a valued member of the Guitar Builders Collective who regularly commented on other people's builds, giving them encouragement and ideas. The whole point of this build-along is to grow the community, to make online friends, to share ideas and inspire others. This year's competition ends on the 23rd of April, and if you're stuck for inspiration, this year we have an optional theme, Use What You've Got. You can find out more via the Guitar Builders Collective forum, the Instagram page, or our